Good morning, good afternoon. Welcome to our webinar, Flash Storage with 24 gig SAS leads the way in crunching big data. Before we get rolling, a couple housekeeping items. Everyone's phone will be on mute during the duration of the call. If you have questions, feel free to enter them in the dialog box at the bottom of the screen. Today we're going to take a deeper look into 24 gig SAS and how it can be used in real-world hyper-converged data center deployments, especially as it regards to Flash. With me today, I have a number of key industry experts to help with the discussion. First, I have Greg McSorley. Greg is a technical business development manager at Amphenol Corporation. Greg currently serves on the SCSI Trade Association Board of Directors. As well, he's a member of the SNIA Technical Council and acts as a liaison between STAE and SNIA. Next, I have Kevin Marks. Kevin is a technologist and distinguished engineer in the Server and Infrastructure Systems Office of the CTO at Dell. For the last 22 years, Kevin has been focused on storage technology and storage standards. And finally, I have Jeremiah Tussey. Jeremiah is the Alliance Marketing Manager for Microsemi's Enterprise Storage and Communications Group. He has over 18 years of experience in the storage industry with focuses on not only application engineering, but product marketing and others. Jeremiah is also on the board of directors of the SCSI Trade Association as well as SATA-IO. And my name is Rick Kutzpol. I'm a product planner at Broadcom, and I'm the president of the SCSI Trade Association. With that, I'm going to turn it over to Greg McSorley, and Greg's going to say a few words about SNIA.
Hi, Rick. Thank you. Hi, everybody. As Rick said, good morning, good afternoon, wherever you are. Yes, as serving on the Technical Council, I would just like to give a short little introduction to who SNIA is and what SNIA is. So basically, SNIA is the Storage Networking Industry Association. It's an association of producers and consumers of computer data storage networking products. Pretty straightforward. SNIA was incorporated in 1997, so they've been around quite a while. As you can see, we have a large organization. We have over 160 organizations as members with more than 2,500 contributing members out of that group. So there's a lot of work going on. As you can see, we have 50,000 users in storage worldwide. So it's a pretty wide-reaching organization. For more information on it, you could check out the website at snia.org. Now I'm going to send it back to Rick and the boys to have a very good webinar. Thank you.
Perfect. Thanks, Greg. So like Greg gave a little intro to SNIA, I'm going to take the opportunity to give you a little information on the SCSI Trade Association. The SCSI Trade Association was founded in 1996, and it's a 22-year-old industry alliance made up of storage leaders representing all facets of enterprise storage. The SCSI Trade Association is made up of 17 active members, ranging from cable and connector vendors to equipment manufacturers to the end devices, the HDDs and SSD suppliers. To learn more about the SCSI Trade Association and sign up for our regular newsletter, go to scsi.ta.org. You can see the web address there at the bottom. With that, I'll get into it. First, I'll level set on where we are from the SAS technology perspective. Currently, we're in our third generation of SAS at 12 gigabit per second SAS. 12 gig SAS has been in deployment since 2013 and has been the staple of enterprise storage during that time. Right now, our focus is really on 24 gig SAS. The 24 gig SAS spec is now complete and has been forwarded to Insights for publication. and a lot of activity is going on in 24 gig SAS. Equipment is being developed and tested actively, and right now we're actively planning our first Plug Fest, which will be in the middle of 2019 at the University of New Hampshire's Interoperability Lab. And then production, of course, will follow closely after that. From a T10 perspective, remember T10 is the technical organization that defines the actual standards itself. Right now their focus is now looking toward the next generation of SAS. Right now we're calling it 48 gig SAS. And it is an approved project proposal, and actual proposals are being discussed and things are in process. So stay tuned on that. There will be a lot more information as we start moving into the 48 gig realm. Today, SAS is the foundation of all aspects of enterprise storage. And in today's webinar, you're going to hear a lot of these messages echoed back and forth. And so what I wanted to do is touch on them real quickly before I turn it over to Jeremiah and Kevin. So these are what we call our pillars of SAS. The first one is dependability. The last 3 generations of SAS have made it very robust, very dependable and reliable, and it's the go-to solution for robust enterprise deployments. The next one is flexibility. Remember, SAS isn't just connecting to SAS hard drives. It's also SAS SSDs, SATA HDDs, SATA SSDs, and so it's very flexible in that regard. And today, over 90% of all end-device enterprise shipments are behind SAS infrastructure. So that's a pretty sizable piece. Then there's scalability. SAS is inherently scalable. Scalable from server deployments with 2, 4, 6, 8 drives, all the way up to very huge deployments of thousands of drives, giving the OEM or the integrator the ability to scale their solutions from very small device, very small deployments, very focused deployments to very broad ones, ranging from performance optimized to capacity optimized and everywhere in between. And then economics. No matter what economic metric you use, SAS with its huge established ecosystem is going to come out in very favorably in most deployments, and so those are the messages that we want you to get out of this today, and so listen for those as we move through the presentation. And with that, I will turn it over to Kevin. Kevin?
Yeah. Yep, I'm here. Just waiting for the slides to move. They're moving kind of slowly. So, anyways, so I'm Kevin Marks in the storage kind of storage CTO group at Dell. I'm going to talk about kind of hyperconverged and 24 gig SAS. So, right, the shift to hyperconverged, right? So we're seeing this shift in some of the use cases and in some segments where we used to traditionally have servers in a SAN and then external storage, whether that would be Fiber Channel or iSCSI, moving to very storage and heavy storage and memory heavy configs with SAS HBAs with no RAID, and that's kind of what I'm showing on the picture. Right, today we ship a lot of our systems that can take up to 24, even up to 30 drives in a single server. And so what's this doing? It's allowing kind of a shift away from a separate storage and server or separate compute and SAN environment to a combined environment. And what this does is it gives the ability to kind of to dynamically shift compute resources and storage resources as your workloads change. You can add more drives in the server. You can add more servers if you need to scale the compute side of it. And that's kind of yielding in my opinion, a less complex management, because now we've kind of potentially put the management pane under a single pane of glass. And this also is, allowing for a tight coupling between the storage and compute orchestration. one thing that it also does is it allows for kind of the use of heterogeneous configs, right? So now these servers can have SAS, they can have SATA, they can have SSDs, they can, some have NVMe, and they can all be used with the software-defined storage or the SDS layer that's running above them. And lastly, the one other thing not directly related to storage is what this does is it seems to increase the east-west network traffic. And, for higher performance, some of them are using kind of RDMA protocols for their SDS solutions. And some examples of these, at least from a Dell perspective, would be our XC series appliances. We have VxRail, we have VxRacks, we have some OpenStack/Ceph configurations, and we have ready nodes for like VMware vSAN and Microsoft Spaces. So what's driving this shift to HCI? So in my opinion, I think one of the main reasons is the rapid innovation, the reduction in complexity. You're getting resource optimizations and cost efficiencies. So in the rapid innovation, right, this is allowing for newer kind of DevOps models, right? Whether you're using VMs or you're using containers, Docker volumes, self-service portals, those kind of things, or even kind of Cloud Foundry integration, because the two are together on the same compute node. You in many cases can get better integration and orchestration. In the complexity area, this gives us a single pane of glass for storage and compute, and like I said previously, you can get some automation of the VM container relationships to storage, and potentially no SAN fabric, right? Or a single networking fabric, depending on kind of security and your use cases. You also can have a single admin and get rack space and hardware reductions because you don't have compute and storage as separate units in the racks. We also get better resource optimizations, and what I mean by that, I'm really talking about core utilization. A lot of people know that in real data centers, even with virtualization, the core utilization has still been relatively low compared to the core capabilities. And putting both compute and storage on the same nodes increases the core utilization. And it also allows for some interesting models around VM container to storage affinity, allowing for increased throughput if a lot of your data remains local to the workload. And lastly, from a perspective of cost efficiency, there's no SAN anymore. And again, better core utilization, and again, a single admin potentially. So how does 24 gig SAS in this shift to HCI? First, obviously speed. 24 gig SAS has doubled the bandwidth from the previous, and it seems to be well matched to PCIe Gen 4. Why this is important? Well, HCI requires a lot of I/O bandwidth since a lot of the I/O is local to the drives attached in the servers, and then it also needs a lot of I/O to go to other nodes through networking, whether that's traditional Ethernet or some RDMA-based protocol. It also adds a reduction in latency in certain use cases. So what SAS did is they added this concept of persistent connections, and they enhanced the edge buffering for SATA devices. So in SAS is if you don't know, is a connection-oriented protocol. And what I mean by that is when the initiator or the HBA in the storage controller wants to talk to a hard drive or an SSD, it opens a connection, and it does that with an open. And then the drive or the fast fabric then makes a connection through the fabric. If there's expanders, it has to arbitrate through the expanders to finally get to where it's going. And then the guy at the end says, yep, I'm ready, I can talk to you, and it doesn't open accept, and that travels all the way back, and that establishes the connection. And that's kind of a locked connection for a period of time, which then commands and data and responses travel through. Well, when you have environments, and especially environments in HCI, you may not have expanders in the way. There is no real what I'll call fabric. There's no expanders. There's no SAS switch constructs in the way. So the point of doing the open, waiting for the device to go, yeah, I can talk, and then respond, was just basically adding latency for no reason. So what we did is we added the concept of persistent connections. And once it's open, they do the open, there's kind of this concept of a keep alive. And keep alive just keeps getting trained. As long as keep alives are going back and forth, the connection never gets closed. And in an environment where all the drives are direct connected, whether SAS, whether SSDs or not, there's no reason to have connection management if there's no ability to have anything other than the one connection between the HBA and the drive. So I added this concept to reduce latency. From a reliability perspective, another thing we did is because we wanted to keep the same kind of channels, right? So what I mean by channels is the same number of board length and connectors, and basically we could design the same kind of server or storage with the same mid-planes, connectors, associated things. We had to add some techniques to ensure the reliability of the channels between the initiators and the drives. So what we did is we added active transmitter training and forward error correction. And active transmitter training is kind of important because at these speeds, what you're starting to see is that even fluctuations in temperature as you boot up a system, so let me restart. So when you boot up a system today, and it's the first boot, it has a certain temperature, right? And as it warms up, and that's when the training is done. So when the links are established when you boot up and they run good. And then as the system starts heating up or you have thermal events in the data center and whatever, things change. Well, this can cause issues of reliability because the training was done based on its current environment. Based on its initial environment, not its current environment. So what we did is we had the ability to continuously kind of retrain and adjust the transmitters and receivers to allow for optimum reliability over time. And then lastly, we added forward error correction, which allows for fixing of errors that the receiver sees up to an extent. And both of these help, or shall I say, allow us to continue to have the same complex channels that we had in prior generations of SAS. And it allows us to not have to go to higher materials or more expensive materials to maintain those same channels. From scalability perspective, SAS, 24 gig SAS hasn't changed. We maintain backwards compatibility with previous generations of SAS and SATA, and device count, and the reach. You want to be by reach, I mean by distance. And while HCI doesn't really have very big topologies because in the HCI model everything's contained in the compute node, it's still important that we maintain the backwards compatibility. From a management perspective, we've maintained the same management layer, including the enclosure management and everything else associated with SAS management. And this is great because it allows us to use all our previous management tools that we were using in traditional servers now in these HCI solutions. And additionally, we've maintained the same kind of hot plug experience handling air support. And this is good because we've had years and years and years of developing, reliability and hot pluggability within SAS and even back in the day, SCSI infrastructures. And as new technologies come along, they learn about these, lovely things of hot plug. And lastly, from a security perspective, we maintain the same security models we've used before. So nothing's really changed there. We still have our TCG we still support the different varieties of TCG SSCs that we've had. And many of the server models and HCI platforms already have built-in support for these TCG solutions. So from all these things added or maintained in 24 gig SAS we believe that 24 gig SAS is a good solution for HCI, considering we can do reduced latency, the higher bandwidth, and everything else associated with 24 gig SAS. And now on to Jeremiah.
Thanks, Kevin.
Yep.
Right.
Hopefully your slide's coming up.
Give it a moment. I know there's a little bit of lag from what we're hearing. Good day, everyone. I'm Jeremiah Tussey. As mentioned before, I'm the Alliance Manager at Microsemi, a microchip company, and also the Vice President of the SCSI Trade Association. Today, I'm going to give a little bit more background, a little bit of flavor into the value of 24 gig SAS and where it plays into this whole enterprise and data center storage space. Okay. So in summary, I want to focus on a summary of where 24 gig SAS is currently within the storage ecosystem. So right now, what we're seeing and where we're heading is 24 gig SAS is a reality in 2019. And some of the supporting data sets for that reality is the fact that SAS continues to be a widely used storage interconnect for today and into the foreseeable future. And some of the supporting factors behind that are the fact that there's still innovations going on in media technologies that are driving the need for speed. Even in this legacy world and existing infrastructure of SAS and SATA, there's still innovations going on to bring it forward on the capacity front and IOPS front. Each step of product evolutions that are coming to market. So SAS 4 is the standard that specifies and defines 24 gig SAS. And this is going to service the next step into the evolution of the need for speed and devices that will help support that. So what the 24 gig SAS will bring to this next evolution is delivering the bandwidth that matches the next generation of PCIe Gen 4 CPU platforms and beyond. So it more directly matches the interface speed of PCIe Gen 4 and minimizes any impacts or any effects of being a bottleneck in the system. So it continues the trend of maintaining the performance natively attached to that new generation of interconnect and on the CPU and platforms. So in addition to that, there's enhanced support for interconnectivity and endpoints. So there's a couple of technologies I'll mention here later that support and provides an overall enhancement and boost to the SAS interface in the next generation at 24G. And then it's also built for the modern IT infrastructure. So there's certain infrastructures that SAS and SATA devices are very well suited, and 24 gig SAS with that evolution will support it even further and bring it into the next decade. And lastly, connectivity and test infrastructure will be ready in the 2019 timeframe, and this is already mostly in place by the connectors, cables, analyzers, test equipment are available even today, and there are expanders and controllers that are coming in the 2019 timeframe, and we'll have a targeted plug fest in the coming year as well to bring all these different portions of the infrastructure together to start testing this out and making things all work together and we'll making sure they're all working together going forward as we have done in the past. Another area I'd like to talk about is kind of the market side of things. So what we see today and what is forecasted from a market perspective is a continuing growth on units as well as capacity. And it's recognized that PCIe is a growing interface, especially in server environments. But overall, the trends and forecasts still significantly depend on capacity hard drive storage, and even SAS SSDs and SATA SSDs. So what I'm showing here is kind of a breakdown of the different portions of these enterprise market units and capacity, with different shades of blue indicating the portions that are serviced by the SAS ecosystem today. And as you can see, there's still a maintaining of a market on the unit side. Even though it's declining, it's still greater than 70% of the enterprise storage drives that will be shipped out 5 years from now on. But even more so, with the trend is more favored towards the capacity growth. And on the capacity front, you still have a lot of capacity hard drives, some capacity coming from SSDs, but all in the SAS ecosystem still maintaining greater than 85% of their overall capacity shipped through 2022. So what it comes down to is, the lowest cost bulk capacity solutions are still hard drives today. There's still trends where SSDs are getting to a better cost per gigabyte going forward, but the hard drives today at a raw level are still maintaining the advantage, and thus the continued growth going forward. And that's all supported by the SAS ecosystem so far. So in summary, through 2022, over 70% of the drives will be SAS and SATA. Hard drives are here to stay for the foreseeable future anyway. And they continue to be a major portion of the capacity that's shipped, with drive vendor roadmaps and for enterprise hard drives continuing to be SAS and SATA. And then there's new technologies that are still emerging that are maintaining the dollars per terabyte, gigabyte advantage for hard drives, as well as improvements on performance metrics, greater IOPS per gigabyte, more efficiency on the storage per platter, and lower performance on amount of power that's being used, and it's just overall improving the ecosystem on the hard drives front and in the SSD front with SAS. In the near term, SSD investments are focused on the NVMe. It is a hot and in-demand market. Current storage system resources are focused to cover all the bases, and that's specifically NVMe currently. But there is still production going on the 24 gig SAS front, where those types of storage media will be available after the initial system launch. So the different technologies I was alluding to earlier that are being innovated in the hard drive and the SSD technology, and more specifically in the SAS space. In general, we see ever-changing capabilities to increase IOPS and capacity in SSDs, hard drives alike. But with SAS and SATA, the innovations are taking shape in the form of SSHD, which is solid-state hybrid drives that have been available for a while, so a combination of both technologies in a unit. So kind of meeting a demand on performance as well as capacity front. But beyond that, on the individual device level, we also have storage intelligence that's part of the innovation front, where you bring in the SAS ecosystem streams and background activity control, which provide more efficiency on hinting and intermixing of data from different applications, reducing fragmentation, garbage collection, all of that. Is part of the SAS standard that identifies ways to make it more efficient to talk to SSD in the SAS topology. And then TDMR is one of those hard drive technologies that increase the efficiency of writing to a track and narrowing the track to where you get more density per platter. And then to go along with that, you have helium that's been added to hard drives, where you get better cooling efficiencies. You get more platters per hard drive capabilities. So less heat, more platters, less air resistance, as effective use of helium. And then SMR, hybrid SMR, those are single magnetic recording advancements and innovations that are still continuing on to increase the density of tracks on the media and the ways to read and write those to those types of drives forward. And then on the more performance side, you have multiple actuator and multi-link, where you have multi-link identifying wide port SAS SSDs for high performance applications, where some of the more recent production announcements have been indicating about 2 gigabytes per second or 400 to 500K IOPS performance on a multi-link SAS SSD. So very, very suitable for the SAS ecosystem as well. And lastly, you have MAMR and HAMR technologies that are coming to market. MAMR is a microwave-assisted magnetic recording. HAMR is heat-assisted magnetic recording. These are two technologies that are coming forward that will bring more density on terabyte bits per inch metric for hard drives to bring greater than 20 terabytes or more capacity storage within the next couple of years. So a couple of supporting links that I have included in here are that support some of these newer technologies that are coming to the market and being innovated in the SAS space. Multiple actuator, as I mentioned earlier. A little bit more detail on that is it's yet another hard drive technology, but this one's targeted more towards improved IOPS per terabyte efficiency, so providing parallelism within a hard drive. So this is one of those things that's been talked about over the last year. Here's a blog link from Seagate for example, for those who are interested in that technology. And then hybrid SMR is more of a conglomeration of what exists in the past to what's coming forward with SMR technology. So you can have a combination of conventional storage and SMR in a single device and have the flexibility to configure it based on your exact needs, whether you're in a data center or in a server environment, HBA, bulk, high capacity storage access, or RAID, higher performance access that's supported with conventional magnetic recording versus the SMR. And then the next generation technology that I mentioned before, with MAMR and HAMR, here's a couple of links that show where those are leading towards. Those have been in the works for the last several years, and they're starting to come to market here in the near future. So moving on into the 24 gig SAS highlights, and where the 24 gig SAS technology really provides its advantages is, we've done a number of enhancements on both the physical layer side as well as the protocol and block level side. And as was mentioned before by Kevin, with 24 gig SAS, you get a double of the effective single lane bandwidth of the 24 gig SAS link. So this provides the higher throughput and the IOPS performance that's required in these ecosystems that are requiring the need for speed. But more than that, providing the reliability, we've added an enhanced 20-bit forward error correction to the protocol to give a more robust data reliability and connectivity. So this maintains the data reach that SAS is brought to the market today, where you can have your 6 meters and beyond worth of copper cabling in between your different architectures in a SAS ecosystem. And further enhancements to that reliability is the SAS4 enhanced transmitter training algorithm. So there was a specific algorithm in place previously, and now it's been enhanced even further. So we have continuous optimal signal tuning throughout the life of the connection. So when you get different effects of heat changes, electrical changes in the system, brownouts or whatever it may be, you can have different effects towards the signaling. So what this allows you to do is to optimize the signal based on these different conditions that could possibly happen. And then getting more on the higher level protocol and block level for enhancement. There's, fairness is one of those things that needed more focus from in the past when you have a mixture of SAS and SATA drives. So there's been fairness enhancements added to give performance consistency across large and mixed protocol topology. So with that increasing as you go to 24 gig SAS, when you have a mixture of 24 gig and 12 gig and 6 gig SAS drives versus 6 gig and 3 gig SATA drives, all in one topology, you have different levels of performance, and this allows you to do more of a quality of service across the topology to make sure there's a fairness in effect. And then, as I mentioned before, storage intelligence, persistent connections, these are some of the new features that have been put into place to increase the efficiency of SSDs and SAS topologies, and gives better latency metrics, better quality of service. So that's just another way that SSDs are still advancing even in SAS, not just hard drives. And then lastly, SMP priority. So SMP is a management protocol that communicates throughout the topology, so you can prioritize these management class communications for these complex and deep topologies that seem to exist in more scale-out architectures. So two examples of primary areas where SAS as well as SATA, supported by the SAS ecosystem. These solutions are in service today. One in particular here I'm showing is in support of the modern IT infrastructure is hyperconvergence. And overall, the hyperconvergence is a consolidation of the network storage and compute resources into a block where you'll have the high-end appliance-based hyperconverged solutions using SSDs, whether that be NVMe or SAS or SATA SSDs. Those are the type of appliances or all-flash arrays that you've seen with SAS and SATA in the past, more in NVMe today. But you can also support SSDs plus hard drives on the SAS and SATA protocol to make a hybrid storage solution for different varying use cases. And that's what's important today is there's all these different use cases, all these different budgets, and SAS and SATA supports a lot of those different cases today, and continues to do so going forward. And then you can assign data and migrate it between different tiers of storage within the single storage compute block, providing the hot and cold data access and pools of different portions of storage and flash and RAM and CPU to improve the whole capability of the cluster itself, localized performance solutions based on what's needed at that time and place. So this whole total architecture supports the four pillars of SAS that we've mentioned before, providing a dependable solution using SAS and SATA with reliable connections. You got security capabilities with the SAS protocol. You have a trusted platform that's been in the market and proven for many years today, and it's just data center ready. Pretty much a plug and play as it is, with no fiddling around or fine tuning things usually. With that, you have the flexibility of being able to use SSDs or hard drives. You're backwards compatible to existing storage infrastructure you might have at hand, and you have scalability where you scale out to the different types of storage, whether it's capacity storage or lots of devices that need to attach. And lastly, economics. You got your performance, your dollars per performance, your dollars per gigabyte. All of these are well suited with SAS and SATA solutions today. So the next architecture, which is a primary area that I wanted to touch base on, is this disaggregation. So disaggregation is one of those solutions that's more SAN-centric. It's been a very big portion of what SAS services today. So it gives you various forms of interconnects between the different pools of storage and server compute, whether that's SAS as a fabric itself, or iSCSI, Fiber Channel, Ethernet, NVMe over fabrics. There's also solutions that provide the interconnect between the different layers of servers and storage. But this has been something that's been serviced by SAS for quite a while now, and it allows you to have different pools of storage, whether it's hot or cold or warm, or hot with the SSDs, whether they're SAS SSDs, some of the highest performing multi-link or even single-link dual-ported SAS drives that give you a write-intensive service-specific application support, or warm environments where you have SSDs and hard drives combined to give you more endurance performance, servicing multiple applications, and then what is a big bulk portion of SAS ecosystem is the capacity cold storage today, which is the ideal dollars per gigabyte performance or capacity metric that's serviced by SMR drives and capacity hard drives today, and being brought forward at a lower cost per terabyte with these new MAMR and HAMR technologies. So overall, you're supporting multiple servers and applications accessing pools of storage through some intermediary fabric, and SAS is one of those that supports this ecosystem and native. In summary, I'll just close it out with basically saying that the 24 gig SAS ecosystem is ready for production in the 2019 timeframe. It's on track for production readiness with SAS 4 analyzers having been sampling since last year. Cables and connectors have been around for a while and are available in new form factors as well as pre-existing form factors that were supported in the previous generation. And we have new SAS 4 controllers and expanders that are coming into the market aligned with upcoming 4 platform launches. New 12 gig SAS and 6 gig SATA hard drives and SSDs will have capabilities that will intersect with 24 gig SAS ecosystem. Specifically, as I touched on before, multi-link SSDs for increased performance, dual actuator for increased performance, and hybrid SMR and HAMR and MAMR for increased flexibility and capacity. So overall, I just want to provide a call to action to everyone today who's involved in the SAS ecosystem and enterprise storage market. We have an upcoming 24 gig SAS plug fest in the 2019 timeframe, and with the readiness trending to 2019 launch as well. Start your designs if you haven't already, and don't forget to participate in the SAS Plug Fest. And I'll pass it on to Rick to close it out. Thank you.
Awesome. Thank you, Jeremiah. So hopefully from this discussion, you were able to get an update about 24 gig SAS and some of its more real intercepts in the technology, from not only from the the speeds and feeds perspective, but also from Kevin's presentation on a real world deployments coming from a Dell architect. So hopefully you got that from the discussion. A couple questions have come through, and so we'll try to address those at this time. And so I'll read them, and then any one of the presenters can take a run at them. The first one is, could you compare the read-write latencies between SAS and NVMe? I'll take a shot at it to begin with, and then if anybody else has a comment, they can comment in. We have actually done some head-to-head comparisons. Now my data is random, 4K random reads. It's specific to 4K random reads, and so it's just one data point. But we took it all the way from the application layer all the way to the media, in doing a read. And what we found is that if we compare, again, NVMe to SAS head-to-head, there is a difference in latency, and it's on the order of about 4 microseconds. But we have to put that into perspective. The total time for that we calculated for an NVMe read was 8 microseconds, and SAS is about 12. Now, keeping that into perspective, you also have to take into account the read times of NAND, right? So traditional enterprise NAND is in the high 100 or high tens of microseconds, so you're talking 80 to 100 microseconds, and more advanced architectures are even pushing beyond that. So yes, there is a difference, but in the grand scheme of things, it is a small piece of the overall budget. Anybody else have any comments on that? Okay.
I mean,
let's see. Oh,
sure.
Go ahead.
Yeah, I mean, your statements are certainly correct, and you know, NVMe does have the advantage if you just look at the protocol stack. I mean, that's certainly pretty obvious, and I've been involved in both since the beginning, so you know, I don't have any favoritism for either one, right? And I think where SAS does better is really in the scale, right? And I mean that in terms of fabrics, right? In terms you can put a lot of drives behind behind a fabric versus PCIe doesn't, you know, scale anywhere near. If you've ever tried to build a system that has a lot of NVMe drives, it's very difficult, right? And it's still a maturing technology, especially around hot plug and those things. And over time, sure. The other side of it is when you have small environments and you're directly coupling NVMe to the root, yeah, it's going to be faster. You know, no argument.
Yep. Okay. Thanks, Kevin. We are running over, and we just have a few minutes left before we'll get cut off by Bright Talk. But I wanted to touch on the rest of the questions. Can you contrast the pros and cons of NVMe versus SAS4? Which of the two are less expensive to implement? This could be a very long discussion, but in general, for very small topologies, like one drive, two drive types of topologies, NVMe will have a strong value proposition there, because then in a direct connect environment. But like Kevin was just saying, as soon as you start to scale beyond more drives than you can directly connect to the root complex, then SAS starts to gain a very significant value proposition when it comes to comparing the cost of deployments. And then one final one is there's a question on PlugFest. Is there a time? Can anybody participate? We're still working on the timing of the PlugFest. We're shooting for the middle of 2019. It will be hosted at University of New Hampshire's Interoperability Lab, like we've done the previous SAS PlugFest. And anybody can attend. You have to register for the event, and